What if I told you that the next passenger airplane could fly faster than the speed of sound, cut flight times in half, and completely change the future of air travel? Imagine leaving New York after breakfast and arriving in London before lunch. It sounds impossible, but it's becoming reality. This incredible aircraft is called the Boom Overture, and many experts believe it could become the world's first successful modern supersonic passenger jet since Concorde. But can this futuristic airplane really succeed where others failed? Why are the world's biggest airlines already placing orders? And what makes this aircraft one of the most exciting aviation projects ever created? Stay with us until the end, because what you're about to discover might completely change the way you think about flying forever. For more than 20 years, commercial aviation has looked almost the same. Airplanes became more fuel-efficient, quieter, and more comfortable, but they never became much faster. Whether you flew across the Atlantic in 2005 or in 2026, the travel time remained almost unchanged. Millions of travelers accepted long flights as a normal part of life. But a small American company had a dream that seemed impossible. Instead of making airplanes slightly better, they wanted to make them dramatically faster. Their goal was simple but incredibly ambitious. Bring back supersonic passenger travel. Not only bring it back, but make it safer, cleaner, more efficient, and more affordable than ever before. That dream became the Boom Overture. At first glance, the aircraft looks like something from the future. Its incredibly long, pointed nose slices through the air like a spear. Its sleek fuselage is carefully shaped to reduce drag while traveling at extremely high speeds. Every curve, every angle, and every component has been engineered for one purpose: speed. Unlike traditional passenger aircraft, the Overture is designed to cruise at around Mach 1.7, which is approximately twice as fast as many commercial airliners today. To understand how impressive that is, imagine a flight from New York to London taking roughly half the usual time. Business travelers could attend meetings on another continent and return home the same day. Families could spend less time flying and more time enjoying vacations. International travel could become more convenient than ever before. But building such an aircraft is far from easy. History has already shown how difficult supersonic passenger travel can be. Many people remember Concorde. When Concorde entered service decades ago, it amazed the entire world. Passengers experienced speeds that no commercial aircraft had ever achieved. Flying faster than sound felt like science fiction becoming reality. Celebrities, business leaders, and world-famous personalities loved traveling on Concorde because it saved precious hours. However, despite its incredible performance, Concorde faced enormous challenges. It consumed huge amounts of fuel. Maintenance costs were extremely high. Only a limited number of passengers could afford tickets. Eventually, commercial supersonic travel disappeared. For years, people believed that the dream had ended forever. But technology never stops evolving. Today's engineers have access to advanced computer simulations, lightweight composite materials, powerful software, artificial intelligence, and manufacturing techniques that simply did not exist decades ago. Boom Supersonic believes these new technologies can solve many of the problems that ended Concorde's journey. One of the biggest improvements comes from aerodynamics. Every inch of the Overture has been optimized using modern digital engineering. Thousands of virtual flight tests help engineers discover tiny improvements that reduce drag and improve efficiency. Even small changes can save enormous amounts of fuel during thousands of flights. Another major difference is the aircraft's engines. Instead of relying on outdated technology, Boom is developing an entirely new propulsion system designed specifically for supersonic commercial travel. The engines must deliver tremendous power while remaining reliable, efficient, and quieter than previous generations. Noise has always been one of the biggest concerns with supersonic aircraft. The famous sonic boom created by breaking the sound barrier prevented many aircraft from flying supersonic over land. Modern engineers are working hard to minimize these effects and operate within international aviation regulations. Environmental responsibility has also become one of the project's biggest priorities. Unlike earlier generations of supersonic aircraft, Boom plans for Overture to operate using sustainable aviation fuel whenever possible. Reducing carbon emissions is becoming increasingly important across the aviation industry. Airlines know that future passengers expect faster travel without ignoring environmental concerns. This challenge makes the Overture much more than just another airplane. It represents a completely new generation of aviation technology. Perhaps the most surprising part of this story is that major airlines are already paying close attention. Several airlines have announced agreements or purchase commitments because they believe faster travel could attract premium passengers willing to pay for valuable time savings. Time has become one of the world's most valuable resources. Saving 3 or 4 hours on an international trip could completely change the economics of business travel. Imagine executives attending multiple meetings across continents within a single day. Imagine emergency medical specialists reaching distant countries much faster. Imagine scientists, engineers, and global organizations connecting faster than ever before. The possibilities are enormous. But enormous opportunities also come with enormous risks. Developing a brand new commercial aircraft costs billions of dollars. Every component must pass extremely strict safety testing. Every system must be certified by aviation authorities before carrying passengers. One small engineering mistake could delay the project for months or even years. That is why every stage of development receives worldwide attention. Aviation enthusiasts closely follow every engine test. Every design update becomes international news. Every successful milestone brings the aircraft one step closer to changing the future of commercial aviation. And yet, one question still remains. Can Boom Overture truly become the world's first successful next-generation supersonic passenger aircraft, or will history repeat itself once again? As development continued, Boom Supersonic knew that promises alone would never convince the aviation world. They needed proof. Every major aircraft manufacturer must demonstrate that its technology works not only in computer simulations but also in real-world conditions. That is why years of engineering, testing, and research became the foundation of the Overture program. One of the company's biggest achievements came with the development of its experimental aircraft, the XB-1. Although much smaller than the future passenger jet, the XB-1 was built to test the technologies that would eventually be used in Overture. Engineers carefully studied its aerodynamics, stability, materials, and flight performance. Every successful test provided valuable information that moved the project one step closer to commercial reality. The lessons learned from the XB-1 are helping engineers refine Overture's final design. Instead of guessing how the aircraft will perform, they now have real flight data that allows them to improve safety, efficiency, and reliability. Safety is the #1 priority in commercial aviation. Passengers often admire an airplane's speed or appearance, but airlines care most about reliability. Every system inside the aircraft must continue working even under the most demanding conditions. The engines must operate efficiently during takeoff, climb, cruise, descent, and landing. Flight control computers must respond instantly to every pilot command. Hydraulic systems, electrical systems, fuel systems, navigation equipment, and emergency backups must all function perfectly. Modern passenger aircraft contain thousands of sensors constantly monitoring every part of the airplane. If even a small problem develops, maintenance crews can often detect it before it becomes serious. Boom Overture is expected to take advantage of these advanced monitoring technologies, making maintenance more efficient than ever before. Comfort is another area where Boom hopes to surprise passengers. Many people assume that flying faster automatically means sacrificing comfort. However, the designers have focused on creating a premium travel experience. Large windows, quieter cabins, comfortable seating, modern lighting, and advanced climate control systems are all expected to provide an enjoyable journey despite the incredible speed. Business travelers may especially benefit from this new aircraft. Imagine leaving New York in the morning, attending an important meeting in London during the afternoon, and returning home the very same evening. That kind of schedule would have seemed impossible only a few years ago. Tourism could also change dramatically. Travelers who once avoided long international trips because of exhausting flight times may suddenly find distant destinations much more attractive. Shorter travel times could encourage more people to explore new countries, cultures, and experiences. However, none of these dreams will become reality without overcoming one major challenge: cost. Developing an advanced supersonic passenger aircraft requires billions of dollars in investment. Research facilities, engine development, wind tunnel testing, prototype construction, certification programs, and manufacturing plants all require enormous financial resources. Every delay increases expenses. Every engineering modification adds additional costs. That is why Boom must carefully balance innovation with practicality. Airlines also face important decisions. Purchasing new aircraft is one of the largest investments any airline can make. Before ordering Overture, airlines must be confident that enough passengers will pay premium prices for faster travel. If demand is strong, the aircraft could become one of the most profitable premium products in commercial aviation. Environmental responsibility remains another major focus. The aviation industry is under increasing pressure to reduce emissions while continuing to serve growing numbers of passengers worldwide. Boom plans for Overture to be compatible with sustainable aviation fuel, helping reduce its environmental impact compared to older supersonic aircraft. Engineers are also working to improve fuel efficiency, reduce maintenance requirements, and increase operational reliability. Every improvement makes the aircraft more attractive to airlines. Another exciting feature is the aircraft's futuristic cockpit. Modern digital displays provide pilots with enormous amounts of information while reducing workload. Advanced flight management systems assist with navigation, weather monitoring, fuel optimization, and aircraft performance calculations. These technologies allow pilots to focus more on safe operations rather than manually managing every system. Meanwhile, airports around the world are also preparing for the future. As faster aircraft enter service, airports may need updated maintenance facilities, specialized equipment, and trained technicians capable of supporting next-generation supersonic operations. The impact of Overture could extend far beyond aviation. Faster global transportation strengthens business relationships, scientific collaboration, emergency response, and international tourism. It brings countries closer together by reducing one of the world's greatest barriers: time. Imagine doctors reaching disaster zones faster. Imagine engineers solving international projects within hours instead of days. Imagine families spending less time traveling and more time together. That is the true promise of supersonic commercial aviation. Of course, challenges still remain. Certification is one of the most demanding processes in aviation history. Aviation authorities will carefully examine every aspect of the aircraft before allowing passengers on board. Thousands of hours of testing, inspections, documentation, and demonstration flights will be required. Only after meeting these extremely high standards will Overture finally enter commercial service. If successful, it could become the aircraft that brings supersonic passenger travel back to the world after decades of waiting. Some people believe this airplane represents the beginning of an entirely new era. Others remain skeptical, remembering the rise and fall of Concorde. Only time will reveal whether Boom Overture truly changes the future of aviation. But one thing is certain. Humanity has always dreamed of traveling farther, faster, and more efficiently. From the Wright brothers to the first jet airliners. From Concorde to today's ultra-modern aircraft. Every generation has pushed the limits of what seemed possible. Now, Boom Overture is attempting to write the next chapter in that incredible story. Will this remarkable aircraft become the future of global travel? Or will it become another ambitious dream that never reaches its full potential? The answer is getting closer with every successful test flight, every engineering breakthrough, and every milestone achieved. And perhaps, sooner than many people expect, passengers around the world may once again hear the sound of the future racing across the skies.